All right, the problem is single number. You're given an array of numbers. One of the numbers appears once in the list, all the other ones appear exactly twice. You want to find what the single number is that appears once. And the idea is to do it in a linear time complexity and constant space. So this is one of those problems that, I mean, at least for me, I really would have not be able to solve it without being told how to solve it, essentially. I think that's just part of the LeetCode experience, where you kind of need to see weird kind of problems to be able to solve those things in the future. I mean, I knew going into it that it was a bit manipulation type of problem, but that still didn't help me because I'm not familiar enough with those operations. But the idea is to use XOR. Let me show you how that works. So let's say, what do we have here? 4, 1, 2, 1, 2. So 4, 1, 2, 1, 2. So the way XOR works, let me write these out actually as binary. So 4, 2, 1, 2, 1. Right? So the way XOR works, if you were to XOR two numbers, and XOR of course means, if you're XOR means you compare two bits, right? You compare, let's say 1 and 0, 1 XOR 0. You say, okay, are these not the same? Are they different? Do they not equal each other? If that's true, then the answer is yes. So this would be 1. I should probably do this in order, just to make it not weird. Which don't get this confused with like the logical, the propositional logic and operator. It's a little, the little caret. I guess I can just do so the idea is to pretty much say, are they not the same? If you have two ones, you have two zeros, it's going to be false or 0. If you have opposite numbers, 1 or 0, and then 0 or 1, it'll be true, right? So this would be 0, 1, 1, 0, right? That's all you're doing. So if we were to XOR the same number with itself, right, it'd be 0, right? Every time you do this, XOR with itself, 0 every time, right? So by XORing itself, it kind of cancels itself out. So if we were to XOR all of these incrementally, right, like have a running total, I guess you'd call it, these numbers doing it twice will cancel itself out, and we can just do that as an example. So we'll take 0, let's XOR it with 1, 0, 0. So these are the same, different. Okay, now this is our new number. So 1, 0, 0. So now we're here. Let's XOR it with this. Right? So this would be 1, 0, 1. Okay, that's our new number. We're now here. 0, 1, 0. XORed. This would be 1, 1, 1. So now 1, 1, 1. XOR with this. 0, 1, 1. So now we have 1, 1, 0. And this. And you can see we end up with this, which is 4, which is our missing number, right? So that's really all the solution is. You're just XORing each number. The code is very, very simple. It's just one of those problems that you don't really know unless you know, which kind of sucks because it feels like, how are you supposed to solve this if you just don't know? But that's why doing a lot of problems is necessary, because you're able to learn these types of I guess properties, in this case of bitwise operations, that you can use in future problems. So yeah, I mean, that's really all the solution is. I don't know if there's anything else to add to it, really. It is important to note that you can do this in any order. I mean, you could have gone in this order like we went, or you could have gone on like this, right? It doesn't matter. So we'll just go through and do that now. So we'll just have our running total. I don't know if total is the right word, because it's like not really a total, but it's like an XOR total. So let's say for n and nums, we just do total, and this is the XOR operator, like I said, the caret. And you can do it shorthand like this, and I think that's literally it. And of course, the number is it's like an integer, but you can still treat it as binary. in a lot of programming languages, do bitwise operations on it. And this is O of n, of course. You're just going through the numbers, pretty straightforward. Constant time operation here with the bitwise. Yeah, pretty easy, as long as you know the trick.